Good day, ladies and gentlemen. We are going to solve this equation, a quintic equation where the highest power of x is 5. Now, how do we solve this quintic equation? It reads as follows: 6x to the power 5 minus 41x to the power 4 plus 97x to the power 3 minus 97x to the power 2 plus 41x minus 6 equals 0. How do we factorize this equation here? To factorize this equation here, it means that we need to find 6 factors, rather 5 factors. So it means that we need to write this quintic equation as a product of factors. So now, how do we find these factors? First of all, I'm going to take the independent term, the term minus 6, and try and find the possible values that can divide minus 6. So minus 6 can be divided by plus minus 6, by plus minus 3, by plus minus 2, and by plus minus 1 last. These are possible values that can divide minus 6. So I'm going to take one of the values here and replace in the equation here. And if that value gives me 0, then that will be the first root of the quintic equation. I'll start with a positive 1. Now, ladies and gentlemen, if I take x, I give it the value 1. Then I substitute 1 in this equation here. What are we going to get? So I see here I have 6x to the power 5. If I replace x by 1, then I'll be having 6 times 1 raised to the power 5, which is 6. There also I'm having minus 6, and I'll be able to cancel minus 6 and 6 out. These two terms will be cancelled if x equals 1. Let's go to the following two terms: minus 41x to the power 4 and positive 41x. These two terms, if I replace x equals to 1 in them, here I'll be having 41 times 1, which is 41. Then here I'll be having minus 41 times 1 raised to the power 4, which is minus 41. So I'll be having a minus 41 and positive 41. I'll be able to cancel out these two terms if x is given the value of 1. Then I'm remaining with a positive 97x to the power 3 minus 97x to the power of 2. So we see clearly here, if I give to minus 97x to the power 2 the value of 1, I'm giving x there the value of 1, this will give me minus 97. But if I'm replacing x by 1 in positive 97x to the power 3, I'll be having positive 97, and this and that will cancel each other. So ladies and gentlemen, I see clearly that the first factor is x equals 1. Now, I have the first factor, the first roots of the equation. Ladies and gentlemen, no need to remind you that a quintic equation, an equation where the highest power of x equals to 5, such equation has 5 possible roots, 5 possible answers. Right here we have the first answer, x equals 1. Now, how do we find the remaining 4 roots? So we are going to take the quintic equation and we are going to divide it by x equals 1, which is this factor. So x, we bring 1 here, so we're having minus 1. This is the bracket that we are going to use to divide the quintic equation here. So now how do we divide that? We divide by long division, right? But that is a long method. So we are going to use one of the easiest methods that we use in mathematics. So the method goes like this. So I'm going to take all the coefficients of the quintic equation. I'm going to list them with the sign. So I'm going to start with x to the power of 5. The coefficient is 6. I'm going to take 6. X to the power of 4, the coefficient is minus 41. X to the power of 3, the coefficient is positive 97. X to the power of 2, the coefficient is minus 97. X to the power of 1, the coefficient is 41. And then, of course, the independent term, minus 6. Now, I'm going to go like this, ladies and gentlemen. The method is quite simple. I'm going to take the value of x, our first root, which is equal to 1, and multiply it with the coefficient of x to the power of 5. So I'm going to have 1 times 6. It is 6. Then I'm going to have 41 minus 41 plus 6. This gives us minus 35. Then minus 35 here times 1, the value of the first roots. This gives us minus 35. So we're not going to have 97 minus 35. This will give us 7 minus 5 is 2. 9 minus 3, it is 6. This gives us 62. Then we're going to take 62 right here times 1, which is 62, and we write it here. Minus 97 plus 62, this will give us 7 minus 2 is 5. 9 minus 3, it is 3, so we put the sign, the negative sign there. So minus 97 plus 62, it is minus 35. Now we're going to take minus 35, multiply by 1. 1 times minus 35, it is minus 35. 41 minus 35, this gives us 6. Then 6 times 1, this gives us positive 6. Then minus 6 plus 6, this gives us 0. This is our remainder. Ladies and gentlemen, our remainder equals 0. So this, the equation that we started with, the equation proposed to us, the quintic equation, can be now reduced when we divide by x equals 1. It is going to be reduced by, we bring 6 down. So we are going to have here 6x to the power of 4 minus 35, x to the power of 3. Then we take positive 62, x to the power 2, minus 35, x, then plus 6, equals to our remainder 0. Ladies and gentlemen, look at that. Look at how we've managed to reduce the quintic equation into an equation to the power of 4. This equation is called quatic. The quatic equation. From a quintic to quatic equation. Now, how do we solve this quatic equation, ladies and gentlemen? We are going to proceed with the same technique. We are going to take the independent variable, the independent value, which is 6 here. So I'm going to take 6 and try and find all the values that can possibly divide 6. 6 can be divided by plus minus 6, by plus minus 3, then by plus minus 2, and then lastly by plus minus 1. Ladies and gentlemen, these are the values that can divide 6. So we are going to continue. How do I solve this equation here? How do we find roots of the equation there? I'm going to take one of the values and I use it by try and error. So if I take a positive 1 and positive 1, for example, if I replace there, if I replace x by 1, these two terms are not going to be cancelled. Because here I'm going to have 6, there also I'm going to have a 6, which will be 12. The same here, if I replace x by 1, I'm going to have here 30 minus 35. they're also minus 35. So I see clearly, ladies and gentlemen, that the roots cannot be x equals 1. If I replace x equals 1 for the reason that I just mentioned, this equation, the quadratic equation, is not going to be cancelled. So if I use minus 1, let us try minus 1 here. If I use x equals minus 1, these two terms, this and that, if I replace in this term x equals 1, so I'll be having 6 times x minus 1 raised to the power 4, which is 6. And that 6, they're not cancelling out each other. The same, if I take minus 1 here, this will be positive 35. There it will be also positive 35, so they're not cancelling each other. So ladies and gentlemen, 1 and minus 1 cannot be used as roots of the quadratic equation that we have in there. So now I'm going to take this second value plus minus 2. So I'm going to start with a positive 2. Now, ladies and gentlemen, if I replace 2 into this equation here, so I'm going to have here 6 into 2 raised to the power 4 minus 35 into 2 raised to the power of 3 plus 62 into 2 raised to the power 2 minus 35 into 2 plus 6. Ladies and gentlemen, I find this to be equal 0. When you do this, the answer equals 0. So which means that our second root is x equals 2. Ladies and gentlemen, we have our second root. This gave us the bracket. I'm bringing 2 to the first leg of the equation, so I'm going to have x minus 2. Ladies and gentlemen, we have found our second factor. The value or the roots of the equation that initially was proposed to us, which is a quintic equation. That's the second root, whereas the first one was x equals 1. Now, how do I find the remaining 5, the remaining 3 roots? So I'm going to take the quadratic equation that is proposed here, then I try to divide it by x minus 2. So how do? I would repeat the same method that we use. We're going to list all the coefficients of the quadratic equation. So the first coefficient of quadratic equation is 6. There's on the right 6. The second one, it is minus 35. The following one is positive 62, followed by minus 35, and last we have 6. Ladies and gentlemen, these are the coefficient of the quadratic equation. Now we are going to take our roots, which is x equals 2, we multiply by 6. 2 times 6, it is 12. So I'm going to have minus 35 plus 12. This equals to 23. Then we put minus here. It becomes minus 23. So minus 23 times 2. This will be minus 46. 62 minus 46. It is 16. 62 minus 46 is 16. 16 times 2, it is 32. Minus 35 plus 32, it is minus 3. Minus 3 times 2, it is minus 6. 6 minus 6, it is 0. This is our remainder, ladies and gentlemen. Now, I have managed to reduce the quadratic equation into a cubic equation. And this cubic equation will be written like this. I'll bring down 6. So we're having the quadratic equation will be 6x to the power of 3 minus 23x squared plus 16x minus 3 equal to our remainder 0. Ladies and gentlemen, look at that. we have managed to reduce the quintic equation into a cubic equation. Now, how do I solve this cubic equation right here? Ladies and gentlemen, when we check properly the equation that we just solved now, the quadratic equation, the root of it was x equals 2, so I can use that root there, but I'm going to take the inverse of the root, so I'm going to have x equals to 1 all over 2. Now, how do I come up with this? It is because I noticed that this equation here, the cubic equation, it is a reciprocal. It is an equivalent equation, if you want to. An equivalent equation. Why? What does it mean? It means that this equation has a root that is the reverse of the answer that we have there. So now, having this, ladies and gentlemen, check. If I replace x by 1 over 2 in this equation here, how we have 0. So are we having this? If I'm replacing x by 1 over 2 into this equation, let us do that. So we are going to have this. We'll be having 6 into 1 all over 2 to the power 3 minus 23 into 1 over 2 to the power of 2 plus 16 into 1 over 2 minus 3. If you do this, of course, the answer equals 0. So this verify the fact that one of the roots for the cubic equation is x equals 1 over 2. Ladies and gentlemen, we have managed to find the third bracket, if I can put it like that, or the third root of the quantic equation that we started with. So this can be written as I multiply both sides by 2, so I'll be having 2x equals 1. So this, bringing 1 to the first leg of the equation, we're going to have 2x minus 1. Ladies and gentlemen, I have the third bracket. Since the question is to factorize the quintic equation, so now we have found the third factor of the quintic equation. Ladies and gentlemen, we continue. We are going to take this binomial, and then we use it to divide the cubic equation. So we are going to have this. We are use the same method. So we're going to have, we list all the coefficients of the cubic equation right here. So the first coefficient is 6, then minus 23, then positive 16, then minus 3. Ladies and gentlemen, we are going to take the root here, x equals 1 over 2. We multiply by the coefficient here, 6. So we're going to have 1 all over 2 times 6. It is 3. Minus 23 plus 3, it is minus 20. Minus 20 times 1 over 2. Minus 20 times 1 over 2, it is minus 10. 16 minus 10, it is 6. Then 6 times 1 all over 2. 6 times 1 over 2, it is 3. Minus 3 plus 3 equals 0. This is the remainder, ladies and gentlemen. So, ladies and gentlemen, this equation here, the cubic equation, can be reduced now to a quadratic equation. And this quadratic equation will be, I carry down 6 here. Then it will be 6x to the power 2 minus 20 plus 6 equals to, our remainder equals to 0. Ladies and gentlemen, look at this. We have managed to reduce the cubic equation right here into a quadratic equation right there. So we are going to continue solving. As we have obtained the quadratic equation here, we see that this quadratic equation here, by dividing both sides of the equation by 2, what are we going to have, ladies and gentlemen? So we are going to have 6 divided by 2 is 3. So we are having 3x squared minus 20x divided by 2, it will be minus 10x, and 6 divided by the 3, it's going to be plus 3 equals to 0. So ladies and gentlemen, this quadratic equation here has 2 roots. Now how do we find this root? We are going to use simply, ladies and gentlemen, we have here a quadratic equation, 3x to the power of 2 minus 10x plus 3 equals 0. Now this quadratic equation has 2 roots rather. So the root will be obtained like this. We're going to have x, 3x minus 1 minus 3 equals to 0. So x minus 3 equals to 0, so x will be equal to 3. This is the first root of the quadratic equation. Then solving the other bracket, we're going to have 3x minus 1 equals 0. So 3x will be equal to 1. Then x will be equal to 1 all over 3. So ladies and gentlemen, these are the roots, the answers, the values of x for which the quadratic equation right here will be equals to 0. So ladies and gentlemen, we have managed to find all the values of x of the proposed equation, which is a quintic equation. So the equation can now be factorized. We have found all the factors. So we are going to write this: 6x to the power 5 minus 41x to the power of 4 plus 97x to the power 3 minus 97x to the power 2 plus 41x minus 6 equals 0. This quantic equation can be factorized as follows. We can have x minus 3, that will be the first factor. The second factor is 3x minus 1, followed by the other that we find x minus 1, then x minus 2, then 2x minus 1. Ladies and gentlemen, these are the factors that this quintic equation has. The factors are 5 bracket, x minus 3, factor of 3x minus 1, factor of x minus 1, factor of x minus 2, and factor of 2x minus 1. These, ladies and gentlemen, constitute the 5 roots of the quintic equation proposed. Ladies and gentlemen, thank you very much for watching this video.